Great! We are at the beginning of a section where you'll see how we can use a Monte Carlo computer simulation to project a company's future revenues and expenses. Let's import two tools that will help us with standard financial analysis. This time, NumPy and Matplotlib PyPlot will suffice. Our goal in this exercise is to predict the firm's future gross profit. For this purpose, we will need the values of expected revenue and expected cost of goods sold, referred to as COGS in brief. We'll start by performing 1,000 simulations of the company's expected revenues. Assume you have considered last year's revenue and you have an idea about the revenue growth rate you can expect. So, the expected revenues for this year are $170 million, and a standard deviation of this figure would be $20 million. To simplify things, let's work in millions of dollars. Therefore, I will assign 170 to a variable Rev M, standing for revenue mean, and 20 to a variable Rev STDev, standing for revenue standard deviation. Good. The next important value we need to specify is the number of iterations. We intend to produce 1,000 simulated observations from a normal distribution. So, in a variable called iterations, I will record the value 1,000. The next line of code will produce the simulation of future revenues. We will apply NumPy's random normal distribution generator, numpy.random.normal. The arguments we have here are the expected mean of revenues, their standard deviation, and the number of iterations we would like to perform. Okay, so we will store this information in a variable called rev. And, as you can see, we have created 1,000 values. Most of these values are close to the mean we selected. That's great. Let's plot these observations and see their distribution. Now, it is even clearer that the simulated values are centered on the mean of 170. It is obvious that almost all data points fall in the region of 150 to 190. The two values equal the mean minus 1 standard deviation and the mean plus 1 standard deviation. For 1,000 data points, we rarely observe scenarios outside of these limits. All right, this is how we can interpret the distribution of expected revenues. And what is the impact for cost of goods sold? Let's scroll down to see how we can simulate this development. Assume you are experienced in this business and able to tell that typically, COGS amount to approximately 60% of the company's annual revenues. 60% of its revenues are spent to produce the goods it sells. And what do we mean by approximately? Well, if the past COGS values were once equal to 55% of revenue, and then 62%, 63%, and finally 55% again, you may reasonably consider a normal distribution with a mean of 60% of revenues, and the estimation of 60% will have a standard deviation of 10%. Be careful not to type 6%. It does not matter that COGS was deviating with 6% of the revenue value. For setting the distribution, it should deviate 10% regarding the mean of COGS. Good. Here is how we can type this in Python. COGS are money spent. Therefore, we should put a minus sign first. Then, the expression must reflect the multiplication of revenues by 60%. Pay attention, please, as what comes next is crucial for this analysis. We will not simulate COGS 1,000 times. This has already been done for revenues, and we have 1,000 revenue data points. We must assign a random COGS value to each one of these points. All right? COGS is a percentage of revenues. This is why the revenue value we obtained must be multiplied by a value extracted from a random normal distribution with a mean of 0.6 and a standard deviation of 0.1. Had we put 0.6 directly, that would have meant COGS always equals 60% of revenues, and this is not the case. Percentage will probably vary, and we have decided its standard deviation is equal to 10%. NumPy allows us to incorporate the expected deviation. Hence, we are taking advantage of this feature by typing the code here. When we plot the results on a graph, we see the typical behavior of the normal distribution. It is interesting that, if you rerun the COGS approximation, you will not always get the same mean value of the observations. They could be dispersed around 80, 90, 100, or 110, and this will be fine. What is important is that every time, the deviation of COGS will be around 10% of its mean. Okay, excellent. We simulated all the variables to calculate the future gross profit. We'll show you how to do that in our next video. Thanks for watching.